Hello and welcome to the Tiling Solutions for Heavily Trafficked Areas CPD from BAL. My name's Allan, Garland and I'm the Specifications Manager for the Southwest. As this is a pre-recorded CPD, unfortunately we won't be able to take any questions during the seminar. If you do have any questions or would like to speak about any live projects, please get in touch using the details on this slide. BAL has a proud history. We were founded in 1962 by the tile manufacturers that constituted the British Ceramic Tile Council. As tiles materials were changing and there were no specific products or guidance for fitting tiles, the industry was starting to experience installation failures. To ensure tiles could be used successfully and grow as an industry in the UK, the council formed a specialist materials company to develop high quality products for tiling installations and provide a comprehensive technical advisory service for the industry. BAL was formed for the industry by the industry, and it's a value intrinsic to all we do today. We have a number of different teams here at BAL who will be able to aid you at each different stage of the project. The Specification team, for example, can deliver any of our 8 RIBA-approved CPDs in practice and also help advise which products to specify. We could even write that M40 or M20 specification for you. Our task team, or Technical Advisory Service team, who are based at our head office in Stoke, are on hand during office hours for market-leading technical advice. Now this is all backed up by our technical and training teams who are available for on-site technical advice, as well as systems training for contractors who may have not used the system previously, and things like moisture tests on newly laid screeds. Within the CPD today we're going to focus on these topics. We'll look at general design considerations, selection of materials, common issues that we might find within this type of installation, how, why and where to place movement joints, load considerations on tiled floors, look at things like impact damage, other considerations, and then we'll have a quick summary and project experience. In this section of the CPD, we'll be looking at general design considerations. Successfully specifying and installing a tiled wall or floor relies on identifying all of the key elements of the installation. These can include substrate, prep, environment and tile type. We'll discuss each of these in more detail during the next few slides. Careful consideration should be given to the substrate to which the tiles are to be bonded, together with the nature of any surface preparation required. The base must be suitable for the surface conditions to which it will be exposed. Adequate surface preparation of the substrate is of course important. Now BS 5385 states that local variations in level for a nominally flat floor should be that when checked with a 2 metre straight edge with 3 mm feet at each end, the straight edge should not be obstructed by the tiles and no gap should be greater than 6 mm. Now, if we're talking about drying times, for example, an anhydrite screed will take longer to dry than the traditional sand cement screed. Now, the anhydrite screed is moisture sensitive and can break down if tiled too early. This is normally caused by excessive moisture being trapped underneath the tiles and then saturating the screed. The surface must also be stable and rigid, and in case of floors, be capable of taking a dead load together with any traffic imposed on it without excessive movement or deflection. The maximum weight limit for tiling to a particular wall background must also be established, allowing 3 to 4 kilos within the maximum weight limit per metre squared for the tile adhesive and grout. Now, dimensionally stable for changing moisture conditions. This is normally based upon sheets and boards. Now, if we take sheets and boards, they must be capable of remaining dimensionally stable whilst in service due to changing moisture conditions. Where appropriate, additional protection must be provided by the application of a suitable waterproofing tanking system. If the substrate to be tiled is not flat and even, any undulations will be reflected in the tile finish. BS 5385-3 2014 recommends that surface regularity of SR1 when fixing tiles using a tile adhesive. No gap underneath a 2 metre straight edge greater than 3 mm when placed anywhere on the floor. If we talk about tanking, looking at a wet room or a shower, we need to protect the substrate. This is for a number of different things. It can protect the integrity of the building fabric and also protect the room from mould and unwanted smells. Priming. If the surface of the substrate is porous, then this could affect the success of the adhesion of the tiles, so it's always worth priming those substrates. Uncoupling. Now this may be required because of the variation in lateral movement between the tile and the substrates. Check the substrates for the ability to crack. So onto the environment. Is it a commercial or an industrial area? What other stresses will the tiles be exposed to? Is it a dry or wet environment? Moisture loading, quantities of water. Are we expecting excessive quantities of water? Traffic load. What type of static and dynamic loading is expected? Will there be hard rimmed or pneumatic wheel traffic as well as foot traffic? Abrasion resistance. Now what type of damage is the traffic going to cause? Is the floor subject to pressure washing, for example? Exposure to chemicals. What are the cleaning regime requirements? Is there any chemical usage? Are there any hygiene requirements? Is it a commercial kitchen, for example? There are now thousands of different designs of tiles to choose from. When installing tiles, if they're installed correctly using the right types of materials and specifications, they can be easy to install, hard wearing and durable. We put a 25-year guarantee on all of our specifications, for example. This allows us to give you the confidence that if they're installed correctly to the right specification, they will be hard wearing, durable, easy to maintain and have lower life costs than some other finishes. Correct selection of a suitable tile is imperative. BS EN 14411 is the standard regarding ceramic tiles, their definitions, classifications, characteristics and marking. The ceramic tiles can either have a porous body, which is approximately 10% water absorption, a vitrified body, which is normally 3 to 6% water absorption, or a fully vitrified body such as porcelain. This has a very low porosity, up to 0.5% water absorption. The standard that covers natural stone is BS EN 12057. BS 5385 Part 4, the Code of Practice for Tiling in Ceramics and Specific Conditions, offers further guidance on the suitability of tiles for floor tiling in specific conditions, i.e. for heavy loads and impacts. For specific conditions where heavy loads are involved, particularly when considering vehicles with hard-rimmed wheels, the strength of the floor will be improved by the use of denser, fully vitrified or porcelain tile types. Further advice should also be sought from a tile manufacturer. We should also remember that the type of tile and the size of the tile selected will influence the choice of adhesives and grouts. We'll discuss this in further detail in later sections. The health and safety law requires that floors must not be slippery, so they don't put any person's safety at risk. One method for testing slip resistance of ceramic tiles is a pendulum test to BS 7976. This device uses a swinging arm to simulate the slipping foot, and it can be used wet, dry or with specific contaminants. Research has shown that the pendulum test is a reliable and accurate way of measuring slip resistance both in dry and wet conditions. For this reason, the HSE have adopted this particular test method. In general terms, the slip potential is classed as below 25 is dangerous or high potential for slipping, 25 to 35 is marginal or moderate potential for slipping, 35 to 65 is safe or low potential for slipping, and 65 plus is extremely low potential for slipping. In reality, no floor surface can be completely slip resistant. If there are any other contaminants present, different levels of roughness will be needed to lower the slip potential. HSE statistics indicate that one serious slip accident occurs every 3 minutes, most of which occur when the floor surfaces are contaminated. This could be with water or grease, etc. When assessing the potential risks of pedestrians slipping on the floor, it is also important to appreciate the causes and means of preventing floor surface contamination. A quote from BS 5385-3, Guidance on the Reduction of the Slip Hazard. It is therefore important to ensure that tile floors are adequately cleaned and maintained using a suitable and appropriate cleaning regime. It is advisable to include this in your specification. The quote of ceramic floor tiles are not slippery when clean and dry holds true. There are different types of ramp tests employed in the industry. The DIN, which is a German test, uses oil as lubricant, and the test subject wears boots with rubber heavily profiled soles. The higher the R rating, the greater the slip resistance. R9 considered the minimum value for use of a tile in a public area. The UK HSL has 2 tests, one using plain water as a lubricant and normal type shoes with 4S rubber soles and heels. Test 2 is again using water, but under barefoot conditions. The CEN, which is European standard, uses a barefoot ramp test. However, a wetting agent is put into the water. This table is a guide to the R ratings as determined by the DIN ramp test and the environment or work areas to which the particular value is recommended. It's also wise to note that as the R rating increases, so does the roughness of the tile. First and foremost, safety in use. This should take into account the floor tile slip resistance both in dry and wet conditions, the solidity of the tile finish, i.e. are the tiles fully bedded in the correct tile adhesive. Now, we need to look at the correct cleaning methods. If we specify an incorrect cleaning method, this could hinder the tile slip resistance in the long term. Movement in the substrate. When we look at the movement in the substrate, we need to make sure we don't have excessive deflection, thermal movement, or drying shrinkage. Also, the correct placement of movement joints could aid with the reduction of cracking in the tile finish. Environmental factors. As we discussed on previous slides, we are going to have a heavy traffic loading, and what's this going to do to the tiled finish? Also, are we tiling in an area like a workshop where we have the possibility of heavy objects being dropped? This could cause major impact damage. We're now going to move on to looking at tile adhesives and grouts. The correct selection of materials. Tile adhesive classification and standards. We have three categories of tile adhesives: cement-based, dispersion and reaction resin. Cement-based normally comes in a bag of powder and is mixed up on site. Dispersion comes in a tub which is water-based and ready mixed, ready for use. A reaction resin is normally a 2 or 3 part product with a resin and a hardener. Moving on to the classifications, we have 1, which is a normal adhesive, 2, which is an improved adhesive. This meets the requirements for additional characteristics. Then we have a lettered system. So F is a fast setting adhesive, normally cementitious only, and that achieves 0.5 newtons per millimetre squared within 6 hours. T, which is non-slip, that's normally used on walls, and then E, which is an extended open time, which is over 30 minutes. This is for cementitious and dispersion adhesives only. The first three are not tested for in accordance with the EN 12004 requirements, but are important to the end user and assist in providing an adhesive which is easy to mix and apply with a good working time. It allows for adjustment of pre-bonded tiles within a given time. BS EN 12004-2 has a test to measure for transverse deformation of tile adhesives. This gives us S1, which is deformable, and S2, which is highly deformable. Grout classifications and standards. In this section we have cementitious and reaction resin. Cementitious is normally, again, a bag of powder, and reaction resin is normally a 2 or 3 part product which you mix together, which is either a resin, a hardener and a colour, or a resin with a hardener and colour mixed together. The cementitious grout has 2 categories: 1, which is a basic grout, 2, which is an improved or polymer modified grout. The lettering system gives us W on the cementitious side, which is reduced water absorption, and A, which is high abrasion resistance. The main difference between a cementitious grout and a reaction resin grout is that reaction resin grouts are more often waterproof. We will now look at some of the common issues found in this type of installation. Stresses may arise as a result of substrate movements, such as drying, shrinkage and moisture movements in the background and thermal and moisture changes in the tiling. These stresses, if not properly controlled, can sometimes be sufficient enough to promote the loss of adhesion or bulging and cracking of the tiling. Next, we'll examine the 3 major forms of substrate movement and the examples of failure caused by them. A general design requirement for a rigid construction finish, e.g. a tile on its bed, is that the substrate or background and base should be capable of supporting the tiles, bearing in mind the tile types of dynamic or static loads and impacts that the tiled installation may be subjected to. Excessive vertical deflection can cause the grout and more severely the tile to crack. Further guidance on this is found in BS 5385-3 2014. When selecting the correct type of adhesive and grout, it is essential that a polymer modified cement-based adhesive is selected conforming with BS EN 12004 and similarly, a polymer-modified cement-based grout should be selected, conforming to BS-EN for a CG2 improved cementitious grout with additional characteristics. Materials expand and contract when heated and cooled at varying rates. Where elevated temperatures are expected, for example over underfloor heating installations or strong sunlight areas like an atrium or a conservatory, problems can potentially arise. If the amount of potential movement likely to occur between the tile and the substrate is not taken into consideration, this could cause cracking or potential debonding. Both BS 5385 Parts 3 and 4 provide further detailed advice on aspects of the effects of both high and low temperatures on a tiled installation. The information of the coefficient of thermal expansion for various tiles and substrates can be found in the Tile Association's technical document on tiling to heated floors. The main consideration to be given to the correct adhesive selection is to ensure that they are capable of withstanding changes due to thermal influences, in particular conduction of heat through the background to the tiled finish and any associated movement due to thermal gradients. A suitable polymer modified cement-based adhesive should be selected, conforming to BS-EN 12004, having a minimum C2 classification. Drying shrinkage is the contraction which takes place in concrete and cement-based mortars as the moisture is reduced and they dry out. Compression stress is built up in the tiling layer, resulting in separation between the adhesive and tile, or occasionally between the adhesive and the substrate. Tiles are then forced up from the background or base, causing the tenting and bulging of the tiles to occur. As a result of this shrinkage, the tile will no longer be able to fit into the space they once occupied. So, as the concrete or the cement base reduces in size, the tiles cannot do so. They will then tent. There are various factors which can influence the amount of drying shrinkages that are likely to take place, i.e. water to cement ratio, particle size of the aggregate, cement sand mix and proportions, etc. The British Standards BS 5385 guidance on drying times is designed to reduce the drying shrinkage and stresses associated with constructional substrates. Replacement of fast-setting or low shrinkage cements for Portland cement, interscreeds and renders will reduce the drying times from a minimum of 3 and 2 weeks respectively to 24 hours before tiling commences. Stresses can result from factors such as drying shrinkage, deflection and moisture movements in the base, and also thermal and moisture changes affecting the flooring. These stresses can sometimes cause loss of adhesion and bulging or cracking of the flooring. Movement joints extending through the tiling and its bed should be incorporated into the installation to counteract these stresses. BS 5385-4 2015 highlights the relationship between movement joint types and anticipated traffic loading. For effective movement joints, we should pay attention to these aspects. Width. It needs to be sufficient enough to permit the sealant to accommodate the expected degree of movement. Joints should be filled with compressible backup material, then topped up to a final level with sealant. Ideally, the sealant should not bond to this backup material, as this would restrict sealant movement and increase the stress. Sealant should only adhere to the opposing faces of the joint, allowing it to compress and stretch more freely. Perimeter joints, a minimum 6 mm cross-section filled with a suitable sealant. Now please note that for calcium carbonate based natural stones such as travertine, marble or limestone, we should specify a neutral curing sealant. Intermediate joints for heavily trafficked areas. These joints may need to be filled with suitable proprietary preformed sections incorporating metal or rigid plastic angles, required to protect the tile edges. Movement joints in the floor tiling should be incorporated as outlined in the British Standard BS 5385 Part 3. Briefly, this document requires that the joints be located over existing or structural movement joints around the perimeter of the floor where tiling abuts columns, curbs, steps or plants fixed to the base. In larger floor areas, the floor should be divided into bays not greater than 10 by 10 intervals. For floors subject to significant thermal changes, divide the floor area into bays not greater than 40 square metres with an edge length not greater than 8 metres. We will now look at impact damage. Impact damage takes the form of a puncture point, usually within individual tiles from which hairline cracks radiate away from it. This type of defect is not very frequent and is almost always associated with environments which are under high mechanical stresses. The main causes for this relate primarily to the quality of installation. If a heavy load or object is dropped onto the tiled floor, a lack of solid support beneath the tiles or air pockets and voids beneath the tiles will help that tile to crack. The tile might not be thick enough. It might not be thick enough to deal with the amount of trafficking imposed upon that floor. Impact can be defined as the application of a high degree of instantaneous force on a minimal surface and is generally negative for ceramic products. Heavy or pointed objects falling on tiles may damage or shatter the surface depending on the type of object, overall mechanical resistance of the tile, and the adhesive and elastic factors involved in the adhesive or substrate system. The determination of impact resistance is addressed in the European standard through measuring what is known as the restitution coefficient. The coefficient of restitution can be determined by dropping a 19mm 28 gram steel ball from a height of 1 metre and recording the rebound height of the ball. The table here shows figures for both coefficient of restitution as determined by the dropping ball test and by the use of a Schmidt hammer for comparative purposes. Here, the types of floor refer to heavy duty, which are factory floors, breweries, supermarkets and bakeries, etc. Medium duty, which is foot traffic, and that includes shopping precincts, office floors, entrance foyers and domestic kitchens. And light duty, which is domestic bathrooms and hallways, etc. When selecting tiles, it should be noted that in general, the greater degree of vitrification, the higher the coefficient of restitution. To avoid possible impact damage, we recommend these measurements to make sure that the tile floor has adequate impact and compression resistance to the intended service conditions. We need to ensure the floor is level to the British standards recommended tolerance. Solid bed fixing is essential. Ensure no voids beneath the tiles as they become weak spots under load and may trap water, increasing the damage. Specifying the correct type, size and thickness of tile. The joints between the tiles should be as narrow as possible, i.e. 3 mm in high traffic areas. The use of low shrinkage proprietary grouts and high abrasion impact resistance. We have 3 different classifications of traffic loading. Light loading areas, which include domestic and office locations. Medium loading areas, which include shopping precincts, entrance foyers and domestic kitchens. And then heavy loading areas, which include supermarkets, engineering premises, for example, garages, heavy vehicles and fire stations, etc. Other considerations. We need to ensure a good floor preparation, and priming, for example, could increase the bond strength of the tile adhesive. A minimum C2 improved cementitious base tile adhesive should be used. BS 5385-4 advises highly deformable S2 tile adhesives are not suitable for use in heavily trafficked areas. And where tiles are to bed in on a cement sand screed, the screed should be suitable for the anticipated load and be tested for soundness in accordance with BS 8204-1. In the area in which the screed is tested, 90% of all indentations should be category A, which is a maximum depth of 3 mm. The maximum joint width should not exceed 10 mm, and proprietary grouts specially formulated with the enhanced resistance to impact and abrasion and low shrinkage should also be used. Typically CG2A or CG2WA grouts should be used where the tile finish is likely to be exposed to abrasive cleaners and requires additional chemical resistance, i.e. garage floors or commercial kitchen, for example. A reaction resin grout or epoxy grout should be used. Now we'd like to talk you through a couple of our most recent heavy duty projects. When flooding hit Lowestoft, one of its first victims was the major car and motorcycle showroom of Lings Honda. The premises disappeared under 3 feet of water and Lings had to scrap more than 150 vehicles. Once the flood waters subsided, it became clear that some parts of the premises themselves would need extensive work. When it came to retiling, returning the Lings flagship to its former glory was not a quick fix. Having to wait for normal conditions was only the first hurdle. Then, the site had to be made ready for tiling. By the middle of February, a team of fixers was on site and working, but it was not just a case of replacing tiles. Support technicians were closely involved, helping to minimise the potential impact of any further natural disasters. The team prepared the floors for tiling and then used solutions to stop damage from the lateral movement in the substrate, and also provide a reduced material consumption and used to ensure a long-term solution that could provide excellent value. London Southend Airport was extended, which included the development of a new departure lounge. More than 5,500 metres of porcelain floor tiles were laid. Floor tiles were laid onto power-floated concrete finish, a hard-wearing substrate often specified for high traffic areas. Due to the substrate and the heavy traffic use, consideration was needed to ensure that the surface was primed and flexible, highly polymer-modified adhesives were used in conjunction with the flexible, highly abrasive-resistant grouts. For installation speed, flexible, ready-mixed solutions could be used on the 300 square metres of white gloss tiles used on the walls of the toilet facilities. To recap, we've covered the best practice industry recommendations by the British Standards and the TTA, the correct selection of materials to ensure longevity of tiling installations, important design and considerations, and then understand how environmental conditions can impact on a tiled installation. Thank you for your time, and if you do have any questions or would like to discuss a live project or even a future project, please do not hesitate to contact me using the details at the beginning of this presentation.